Good evening, Lamai. Right. Let's start the session today. Right? Okay. Right. So we are with the conversions. Right. Note number 1 and 2. Right, have been discussed. Right. So now we are leading up to the note number 3. Note 3 right? Let's quickly discuss about what we have learned last day and how that thing relates to the today's lesson, right? So last day we had done this kind of stuff, right? Last day our discussion was about so like this. So these kind of things now. So we may have started with this kind of stuff, right? And finally we were supposed to come up with this or kind of this, right? So come up with this kind of a thing to ultimately produce this kind of fun. Right? These are the things we had done last day, last week. Right? Today we are going to discuss about, we are going to start with these things. See, to derive this. See, or else like this. To copy something like this. ඊසති කරේ මේ වගේ වැඩ. දැන් මේව හරි. හරි. අද කරන්න යන්නේ මේ වගේ සී. මුලින්ම කරන්න යන්නේ මේ වගේ වැඩ. අද වැඩ හුඟක් කරන් තියෙනවා. හරි. මුලින්ම කරන්න යන්නේ මෙන්න මේක. හරි මේ දැන් ඔයාලට මොකක් කරේ මේ වෙනසක් තියෙනවා මොකක් කරේ මේ දෙකේ. right? අන්නේ වෙනස මුලින්ම දකින්න තමයි පළවෙනි කාරණේ මෙතන තියෙන්නේ. The first thing is that to identify the difference, identifying the difference between the stuff we have learned last day and we are going to start up with here today, right? Hari. Then මේ දෙකේ වෙනස පොඩ්ඩක් කතා කරොත් මෙහෙමනේ. Actually last day what we have learned is we had a carbon chain. We had a 3 carbon chain. We had a 3 carbon chain. So as the reactant, as the starting compound, and at the end as well we had a 3 carbon situation. 3 carbon or 4 carbon. Anyway, with the last day stuff, the carbon chain bond changed when going from reactants to the ultimate product. When going from starting compound to the ultimate product, the carbon chain bond changed, as well as the functional carbon bond changed with the last day stuff we have learned. Same carbon chain and the same functional carbon with the starting compound and the final product. That was the things we have learned last day. So there we had discussed how to change the functional group. That is the major stuff we have discussed with the note number 1 and 2. How to change the functional group. You are with the same carbon chain with the same carbon as the functional carbon, and we have last day we have discussed about how to change the functional group. Basically with the note number 2 we had discussed that NH2Br and OH is with kind of a right, those are related actually, and then the OH, the alcohols are related to the aldehydes, ketones, and with the secondary alcohols you can think of forming ketones. With the primary alcohols you can think of aldehydes as well as the carboxylic acids. So change of functional group with the same functional carbon. The same functional carbon appearing, changing of the functional group. That is what we have learned last day. But today we are going to start up with something different. See here. Okay, the same carbon chain appears, but the functional carbon is not the same. The functional carbon is not the same. Right? So you can't simply get this one by just converting this into OH and coming up with a PCC. Just converting this into OH by adding NaNO2HCl and then adding PCC won't give you this. That will give you some double bond oxygen on this carbon. Right? So here we have to do some more. So here as well, you won't get some addition of lithium aluminum hydride and then adding some HBr to this thing won't give you this. Lithium aluminum hydride will give you this OH here, and adding some HBr will give you the Br at the second carbon, but not here, not at the third carbon. So that is the new stuff we are going to learn today. How to come up with the correct carbon in your chain as your functional carbon. That is what we are going to start up with. How to come up with the correct carbon as your functional carbon. So here, your functional carbon is at the corner position, but we need that functionality to this carbon to come up with the product. To form the product, we need the functionality to this carbon. So change in the functional carbon. How to come up with this correct carbon as the functional carbon. That is what we are going to start up with. Right? That is all about the note number 3. Right? Coming up with the correct carbon as a functional carbon. Right? So today we are focusing on these things at the start. Right? Let's see what we can do to change the functional carbon. That is the stuff we are going to start up with. Right. So this is note number 3. Right, note number 3. Note number 3. Okay. So I had given it a name, right? But I'll simply write it like this. This is all about, right, coming up with the correct carbon as the functional carbon. Right? Note number 3 is all about this. Right? I have given a name to it, right? As repeat the same, addition plus elimination, vice versa. That was the name I have given. Addition plus elimination, right? Vice versa. Let's discuss what this means. This is just a name given by me, right? Right. See. So here, to come up with the correct carbon as the functional carbon, we have two techniques. We have two techniques. The HBr technique or the H2O technique. Let's discuss about that thing. Here, basically the two major rules we are using is the Markovnikov rule and the elimination rule, right? According to the Markovnikov rule, we are going to add HBr's to your alkenes, and according to the elimination rule, we are going to remove HBr's to produce the alkenes, right? That is what we are supposed to do. So we are using Markovnikov rule to add H2Os to the alkenes, and we will remove H2Os from the alkenes with the use of elimination rule. Right? The Markovnikov rule and the elimination rule are going to be the two things we are going to use here. Let's see how to do this stuff. right? Let's say I'm giving you the HBr technique. See, you are with this. See, you have started with this, right? Then you need the functionality. You need the functionality to the center. See, this kind of a thing should be done, right? So you have the double bond here, but now as the product, you need the double bond to here. You need the double bond to here, right? That is what we need to do. That is what we are supposed to do to produce the compound, ultimate compound. See what I can do. This is very easy. This is very, very easy. First I'll add a HBr molecule. I'll add a HBr molecule by just put some HBr to the flask containing this to add some HBr molecule, right? So it will look like this according to the Markovnikov rule. The hydrogen will be added to the carbon with higher number of hydrogens. So hydrogen will be added here. The Br will be added here. So Br will be added here. The hydrogen will be added here. So it becomes HCH3, right? Br will be added here. Then I'll remove some HBr. You know what is needed to add it. I'll add that thing ultimately. Just remove the HBr. Just think of the thinking process. Let's discuss about the thinking process here. Let's remove an HBr. So what would happen? This Br should remove from with one of the hydrogens at the adjacent carbons. Br should remove with one of the hydrogens at the adjacent carbons to the Br connected carbon. The elimination rule. It should be removed. Which hydrogen should be removed? That is this hydrogen. From the carbon bearing least number of hydrogens, the hydrogen should be removed. Not here. That is the elimination rule. So that when H and B are removed from here, your double bond comes with those two carbons. When a B are removed from here and hydrogen be removed from here, the double bond comes to here. So that is your final product. See, for that you need to add some alcoholic KOH. See, by doing some addition and elimination, you were able to, right, shift the functionality to the center. By doing this thing, you will always be able to shift the functionality to the center, coming up as a center carbon, as a functional carbon or functional carbons. So earlier you had these two guys as your functional carbons. Now you are with these two guys as your functional carbons. The functionality came to the center by doing this thing. Let's discuss another example. See, you are with this one, right? Let's see, you are with this stuff. You are supposed to come up with this one. What is the major difference you see? You have this carbon as your functional carbon at the starting compound, and at the end you are with this carbon as a functional carbon. So functionality should be shifted to this carbon. So what can we do? So for this thing, First you can remove an HBr. Addition, elimination, or elimination, addition, vice versa. Addition, elimination, or elimination, or addition. So then that will give you this. So this, with this Br, this hydrogen will be removed. There is no choice there. Only one adjacent carbon is appearing. So definitely from that you have to remove the hydrogen. So one of the hydrogen will be removed, right? Giving you the double bond there. Right? With this Br, one of the hydrogens will be removed, forming the double bond there. So one hydrogen removed, so you are removing it only one hydrogen. Then if you add some HBr, this is what is going to happen. If you add some HBr, the hydrogen will be connected to here. Right? Out of the two carbons we are in the 5 bond, the carbon with higher number of hydrogens gain the hydrogen, and to the other carbon Br will be connected. That is it. So for that, you need to just add HBr. See, very easily you can, right, shift the functional to the center carbons by doing this. Right? This is the use of HBr, the HBr technique. Adding HBrs and removing HBrs until you come up with the bonded carbon as your functional carbon. Repeat the same. We'll discuss about that thing later, why we say so, right? Anyway, addition, elimination will give you, or elimination, addition will give you, right, the correct carbon as a functional carbon. Right? We'll discuss the same thing with a water molecule as well. Adding a water molecule and removing a water molecule. The same logic is used, right? The same logic is used, right? See, to do these two conversions, right? Let's come up with some water. Come up with some water. The same logic, the same thinking pattern. To do these two stuff, let's try to come up with some water removal. Right. Let's start with this water technique to come up as the functional to the center, taking the functional to the center. Right. See. So the functionality is here. We need the functionality at here. Taking the functional to the center. Right. So what we can do? First, just add some water molecule. Add some water molecule. Adding water means just adding dil H2SO4. That will give you this kind of a molecule. Right? To the carbon with higher number of hydrogens, the hydrogen will be added. That means this one. This guy is with more number of hydrogens. And to the other carbon, the OH will be added. Right? To the other carbon, the OH will be added. To the carbon with higher number of hydrogens, the hydrogen will be added. Right? Then we can remove an HBr molecule. Just remove an HBr molecule. Sorry, remove an H2O molecule. We are using the H2O method here. So to remove the H2O molecule, you need the concentrated H2SO4 and some heat. So when you are doing so, this OH will be removed. That OH will be removed with what? With one of the hydrogens from these adjacent carbons. Actually, from the carbon, we are in least number of hydrogens. Out of the adjacent carbons, we are in least number of hydrogens. The hydrogen will be removed. So that is this one, not this. So that the double bond will form at these two carbons. That is what we need. Right? So the H2O technique or HBr technique can be done to do so. Let's do the same stuff with this one. You have OH here. We need the OH to here. So we need the function to this carbon. So we can shift that thing with the use of this technique. Right? First, remove an H2O molecule as oxygen is there here. First remove an H2 molecule by just coming up with conc H2SO4. That will give you this. When removing an H2O molecule, OH will be released with a hydrogen here from the adjacent carbons. No choice there because only one adjacent carbon is appearing. So then if you add some H2Os to this thing, you will come up with that one because the hydrogen will be gained by the carbon which is with more number of hydrogens, the Markov rule. The other carbon will get the OH, right? So for that, del H2SO4 can be added. So we can easily shift. We can easily shift the functionality to the center of the carbon chain by these techniques. One of these techniques, right? So that is the major stuff with the note number 3. So I'll do another example before going for the practice questions appearing in your note. I'll do another example for this one, right? Now you are very clear why I have named the note number 3 as addition, elimination, or vice versa. Addition, elimination, or elimination, addition. Right? This thing is understood now. Let's discuss why I have named this note as repeat the same. See, what is the importance of that thing, that wording. Right, let's do. See, I'll do a good conversion using this method. Right, let's think that, right, do I have a good mark? Yeah, let's suppose this kind of a thing. So we are starting with this stuff. See, a good thing to do here. Okay, let's start with I'm starting with this one and I'm supposed to produce this thing. Right? Okay. Sorry, you don't have this, no? Yeah. Right. Let's see how to apply this technique to do this kind of a conversion. First thing is the observation. Right? First thing is the observation. You have to observe. Right? What is the problem is. First observe what is the problem here is. Right? Let's observe what is the problem, what we need to do here is. So the problem is, you are with the same carbon chain, no worries with that. You are with the same carbon skeleton. The same carbon skeleton also appears here as well. No worries with that. Right? But what is the thing we need to do? So we have a different functional carbon. Different functional carbon we have with. Right? So first what we need to do is, first we have to take the functionality to this carbon. We have to take the functionality to this carbon. That is our first task to do here. If you can take the functionality to this carbon, right, then we can come up with the NH2 to that carbon. So taking the functionality to this carbon is all about the HBr method or the H2O method. This one, note number 3. Let's do the conversion. Right? So this is how we think. We have to take this one. So this is all about note number 3. This is all about note number 3. Right? Let's do. First of all, to to take the functionality to here, to this kind of a center position, to do this thing, to do this node number 3 thing, first of all, we need to come up with a OH or a BR. You need to come up with a OH or a BR. You can't remove the NH2 stuff, no? We can remove an HBr or a H2O. We can add a H2O or a HBr to do this process, to achieve this goal. That is what node number 3 is. So that first of all, you have to convert this thing to a Br or to a OH. Then only we can go for the change. Let's convert this one to a Br or to a OH. So we can convert that thing like this. So NH2s can be converted to, right, OHs easily by just studying, right, NaNO2HCl. We had learned this thing with the note number 2 last day. Now we are happy. Now we are with the OH. Now we can do this technique to take the functionality towards here, right? Okay, let's do. Until you come up with this carbon as a functional carbon, repeat the same. Do the elimination addition, repeat the same until you come up with this carbon as a functional carbon. Just do this. So first of all, you can remove an H2O by adding conc H2SO4. So that will give you this. This OH will be removed with one of the H here. Right now? Then you can add a OH here. Then you can add an OH here by adding an H2O molecule. So that will give you, right, this stuff. Adding a H2O molecule is del H2SO4. That will give you this compound CH3, CH, CH3. So according to Markovnik's rule, if you're supposed to add some H2O here, the hydrogen goes to the carbon with high number of hydrogens. So to their hydrogen goes, to the other carbon, OH goes, while you are removing this double bond. Markovnik's rule, right? So we'll come up with OH here and CH3 here. Right? Now we need to come up with here, right? Repeat the addition, elimination, until you come up with the carbon you need as the functional carbon. Repeat the same. So let's do the process again. I'll write it here. Right? Let's remove some H2O with conc H2SO4 and heating. Right? We need to heat, right? In adding conc H2SO4. So that will give you CH3. This OH will be removed with this hydrogen, because that is the adjacent carbon with low number of hydrogens. With that one, the hydrogen will be removed. So when you are removing hydrogen from here, the double bond will form here. Right? So double bond is there. Repeat the same until you get your interested carbon as your functional carbon. Then do the thing. Del, right? Del H2SO4. That will give you this one. The OH will be connected here because this carbon is the one with the more number of hydrogens. So hydrogen comes here. The other OH comes here. Right now? CH2, CH3. Then you need to convert that into NH2. OH can't be converted directly to the NH2. first of all, actually now we are done, right? Now we are happy, right? Now we got the functional carbon, correct carbon, right? Now we are happy. Now what we need to do is just do the note number 2, note number 1 stuff. Just change in the functional group. Just change in the functional. Now we are done with the correct functional carbon. Now what we need to do is just change in the functionality to NH2. Just change in the functionality to NH2. So OH to be changed to NH2. So that can be done by first converting the OH to Br and finally to the NH2. See, and final thing can be done to come up with the products, right? Now no need to connect the stuff to here, right? No worries, you can yes, you can connect the stuff. I'll connect that thing. It is not needed, right? That is not needed, right? So you can just write the product here, right? So if you connect that thing, so the thing should be added is what? NH3. That will convert the Br to NH2, right? Here it will be the HBr. Right? That is how we are supposed to do a conversion. It may look like bit longer conversion, but the thinking process is very simple. Thinking process is very simple. Right? What we need to do is this. Until you come up with the wanted carbon as the functional carbon, repeat the same, repeat the addition elimination, repeat the elimination addition, the vice versa. Right? Until you come up with the correct carbon, the wanted carbon as a functional carbon. So according to the Markovnikov rule and the elimination rule, that is what happens. Actually, no need to check for the Markovnikov and the elimination rules when you are doing this process. That thing will happen, right? Without a doubt, it will happen. No need to check whether I have written that thing correctly according to Markovnikov, according to the elimination, whether I have written that correctly. No need to check. Actually, that is what happens according to theories. You can check for the first, second, third conversions if you're not still with some confidence with this thing. But when you have gained some confidence, no need to check for the Markovnikov and the elimination. That is what happens. That is what happens, right? What happens is actually the functionality will be taken to the center carbons by this technique. Functionality will be taken to the center carbons by this technique. Right? So if you need to take the functionality to the corner carbons, you may have to come up with the anti-Markovnikov. Something to think, right? You may need that knowledge when you are doing the last 2 questions of your question set, right? But normally, to come up with the functional carbon at the center, this is the method, right? Now, so you can copy this one if you need an example for the note number 3, some example, right? And then you have 7 conversions to do, right? In your note. The page number 2 and page number 3 is with 7 conversions, right? So just start doing, right? I'll do one by one with time, right? But first copy this thing, and I think you got the idea correctly, right? Then we can continue, right? So just do the practice questions. Just start now. With some time intervals, I'll do one by one, right? First, you try to do this thing, right, in your own, right? Then you can correct after I am writing that thing in the board. Just do that. So what we are supposed to do? So basically, you need to take this functionality to here. That is what we need to do. Right? Between these two carbons, you have to take the functionality. You have to change the functional carbons. Right? Okay, let's do the stuff then. Right. First of all, we can add some HBr. Let's go for the HBr method. Let's add some HBr like this. So Br will be always connected to the carbon with least number of hydrogens. As the hydrogen is connected to the carbon with greater number of hydrogens, the Br will be connected to the other carbon, right? Then we can get rid of that Br as HBr molecule, so that this Br will be removed with this one. Always functionality will come to the center, right? With this technique. So CH3. So one hydrogen will remain as one removed, right? So for this thing you can add HBr. To remove HBr you can come up with alcoholic KOH. Then you need to take the bond here, right? So first come up with the kind of HBr addition. Repeat the same, right? That is what I am doing, right? So it's like this now. And finally, get rid of this Br with this hydrogen. So always with the adjacent carbons, the least hydrogen containing carbon will release its hydrogen. So this Br removes with this one, not with this one, but with this one, so that your final product will form. That is by addition of alcoholic KOH. So for this thing, you can add HBr. That is the question number 1, right? ඊළඟ exercise එක කරමුද ඕන? Number 2. So you are starting with this one. CH3CH, CH3, CH2, CH2OH. You are starting with this case, right? This one, and you are supposed to produce this thing. CH3C, CH3, and you have a Br. ඔතනයි වගේ ටාස්ක් එක. හරි. හැමදේටම ගන්න බලන්න මේ හරියට අල්ටිෆයි කරගන්න මේ මුලින් බලන්න මේ වාගේ කාබන් චේන් එක එකමද කියලා. So you have 1 2 3 4 carbons. There are also 4 carbons, and with the second carbon you have a CH3, right? Okay. Carbon chain is same, right? අපි ඊළඟට කතා කරනවා මේ කාබන් චේන් එක වෙනස් කරන හැටි ගැන. note number 4 වල කතා කරන තනිකරම මේක ගැන. අපි අද ඒ වැඩේට යනවා. මේක වැඩි ඉවර කරලා. හරි. තොර මුලින්ම කරන්න ඕනේ ඒක තමයි හොඳේ. මුලින්ම කාබන් චේන් එක චෙක් කරන්න. තාම අපි කාබන් චේන් වෙනස් කරන එක ගැන කතා කරන්නේ. ඒ නිසා දැන් මේ questions ටිකේ කාබන් චේන් එක වෙනස් වෙන එක නැහැ. නමුත් ඒක තමයි මුලින්ම කරන්න ඕනේ. conversion එක ගත්තම මුලින්ම කරන්න කාබන් චේන් එක the carbon skeleton එක හරිද කියලා බලන්න එක. So you are with a carbon skeleton which is not going to change here. 1 2 3 4 I think is there. 1 2 3 4 is there, and CH3 is there. Right? That is okay. Now what is the difference here? The difference here is you have the functionality at this carbon at the starting compound, and functionality at this carbon at the required compound. So functionality should be changed from here to here. That is what we should do first with this one. Let's do the stuff. First of all, remove some H2O by adding conc H2SO4. So that will give you this one. So when you are removing H2O, this OH will removed with one of the hydrogens here. So only one hydrogen appears, and that carbon, 2 carbons will get a double bond, right? Then you can add some H2O. So to remove the H2O, you need to heat as well, right? To add the H2O, just come up with H2SO4. To add some H2O, you need some reagent with more H2Os, right? That is what dilute H2SO4 means. So just adding H2O, so hydrogen comes here and the OH comes here. Hydrogen will be added to the carbon with more number of hydrogens, right? The OH comes to the other carbon. So that will look like this. OH comes here. Right. Then we can remove the H2O. So we need the functionality here, right? Until you meet the correct carbon as the functional carbon. Repeat the same. Repeat the process. So to get rid of H2O, you can come up with conc H2SO4 and some heat. That will provide you CH3, CH3. So this hydrogen will be removed with this hydrogen, right? This OH will be removed with this hydrogen, right? So that is the adjacent carbon with low number of hydrogens. Out of these two, these are two adjacent carbons. So it will be removed with this, right? No need of thinking of that, Lamai. So that will happen eventually. Functionally, will be centered. Right? Now you can come up with a H2O molecule to give you here OH, and then you can convert the OH to Br. Or, right? Simply, you can directly convert this into this one by just adding HBr. Right? So by just adding HBr, the H comes to here. No? Out of the two carbons which is with the greater number of hydrogens will gain the H, and the Br will be taken by the other carbon. That is okay. That can be done. Right? So that is your conversion. We have this one, CH3, CH2, CH2, CH double bond CH2. You are supposed to convert this one to CH3, yes, that is what we are supposed to do here. See how to do this thing. So here also we see now still the functionality is at these two carbons, right? Functionality is at these two carbons, right? But we need the functionality to here, to the third carbon. We need functionality to this one, right? Functionality should be taken to here. That is how we think, right? So the carbon skeleton is same, but the functional carbons differ, right? So we need to take the functionality to here first of all. After taking the functionality to this carbon, then we can do these same makeups. After taking the functionality to this carbon, then we can do the makeups. These are makeups, right? So just coming up with the ketone. First, our goal should be to come up with this carbon as a functional carbon, right? Okay, let's do the stuff. So, right, do we have? So let's convert the stuff. So I'll go with the black color now, it's better. So we can take the functional to here by just adding HBr, right? Functionally come to the cone normally. So this guy get the Br, while this guy get the hydrogen. Right? Then that thing can be, so you can take the function to here by removing NHBr. So one of the hydrogens from here will remove. Right? These are two adjacent carbons. One of the hydrogen will be removed from here, right? So basically the function will come to the center, right? Then you can add a Br here, HBr. So come up with the functional as here. That is what we need. That is the carbon what we need as the functional carbon. So at this case, you can just come up with the H2O as well, right? Because you know the oxygenated compounds are related with the alcohols, no? The oxygenated compounds are related with the OH. The oxygenated compounds are related with the OH, right? So OH gives you the bridge between the oxygenated compounds and the BrNH2 stuff, right? Between the oxygenated compounds and the other polar compounds, the bridge is provided by the OH. That is what note number 2 says, right? So it's better to come up with the OH rather than going for the Br here, right? Both can be used, right? So that is going to be CH3, CH2, just coming up with the OH here. Hydrogen is there, so OH comes here. We can take the H here. No worries there because it's a symmetric situation, right? So we are not violating any kind of rule by adding the H here and the OH here, right? Because both hydrogens are with same number of hydrogens, carbons are with same number of hydrogens, no worries, right? So this can be done with the H2SO4. To do so, you need the alcoholic KOH. So finally, the OH is converted to this thing. So that can be done, right, with the use of PCC or even the KMNO4. Right? You can use the PCC in this case, or one can use the H plus KMNO4 as well. Or you can use, writing one is enough, right? Don't write both. Or you can come with H plus KMNO4 or H plus dichromate. The secondary alcohols can be converted to the ketones, the carbonyl compounds with 2 R groups, the two same R groups, right, by H plus KMNO4 as well, right? Okay, no? That is the question number 3. Right. Let's do the fourth as well. Right. The fourth thing, right, is written like this now. The fourth case, right? This one. This should be converted to this thing. Right? Okay. Let's do the stuff. Right? So basically, first thing to do is actually observe the carbon skeleton and see whether the carbon skeleton is changed or not. No, carbon skeleton is not changed here. You have 1, 2, 3, 4. 4 carbons here. 1, 2, 3, 4. Then you have a branch carbon, right, from the second carbon. So carbon skeleton won't change. So what have changed here is actually you have the functional carbon here at the starting compound, but at the final compound you have the functional carbon here. So you need to take the function to this carbon first of all. After that, you can do these makeups. Right? Then H2s, right? Okay, first let's take the function to here using the H2 or the HBr method. So to change the functionality to the correct carbon, you can use the H2O or the HBr method. For that, first of all, here you should have a Br or a OH. So that first we need to convert this into a Br or a OH or an OH. Then only we can change the functionality to come up with this carbon as a functional carbon. Right? First convert this into OH then. This is the easiest. So by adding lithium aluminum hydride in dry ether medium and doing some acidic makeup, you are able to come up with OH here. So the primary alcohol could be made with the same R group by adding an lithium aluminum hydride to the aldehyde, right? This is what we have learned with the note number 2. Right, so CH2 is going to be this thing, no? So CHO group will be converted to CH2OH, keeping the same R group. This is what lithium aluminum hydride do when adding it to a aldehyde, right? So let's do the change. Let's try to change the functionality, change the function of carbon, right? So this just removing an HBr, sorry, removing an H2O, right? And then add some H2O. Add some H2O. Right? Then remove some H2O. So that this hydrogen will remove, right? Then add some H2O until you come up with here, do the things, right? So you can add some H2O and then the OH can be converted to Br and then the H2. Oh, one can first convert this thing to, I'll go like that. First one can convert this into Br, no? Simply. You can convert this into Br. It is easy to come up with the H2 rather than coming up with the OH. With Br, it's easy to come up with the H2 with one single step, right? So I'll add some Br then. So functionally came to this carbon, right? Now we are happy by adding some HBr. Rather than at this stage going for the H2O addition, I'll went with the HBr addition, right? So that Br comes, right? Because with that I am able to come up with this thing with one single step. If it was the OH here, we need 2 steps to come up with here, right? So nothing is done. Just adding NH3 will give you the final result. So let's write this stuff here. So for this you can add HBr. To do so, you need to remove some H2 molecules. So concentrated H2SO4 should be added with some heat. To do so, adding some water molecules. So the H2SO4 can be added. For this stuff, it is the removal of H2O molecules. So concentrated H2SO4 will be added with some heat. Right. So that is our conversion here. The fourth stuff. Let's just do the other 3, 5, 6, and 7, and then we can discuss those. Question number 5. Right, you have this thing. So CH3, CH2, CH2, COOH, right? That should be converted to this Right. First of all, observe whether you are dealing with the same carbon skeleton. Yes, you are with 1, 2, 3, 4, 4 carbons, straight chain. 1, 2, 3, 4, 4 carbon chain, straight chain, right? So you are done. Next thing you are looking for is the functionality of functional carbon. So you have you are with the functional carbon here at the starting compound, but at the end you have some functionality here, right? With these two carbons, right? So anyway, you have to take this functionality to here, no? Here, things like here, right? Okay, to between the second and third carbons, right? So let's do the stuff. So to change the functionality of carbons, right? To change the functional carbon, right? You need to come up with the HBr or the H2O method, right? For that, first of all, you need to come up with a Br or OH at that carbon. Then only that H2O or the HBr method can be applied. Let's do that, right? So first convert this thing to OH. So that can be done. The CH, this section can be converted to CH2OH, right? By just adding lithium aluminum hydride. So it's a reduction, adding hydrogens. So that can be done by lithium aluminum hydride, right? So next, then this thing, so we can change the functionality now, right? By removing an H2 molecule. So one of the hydrogen from here will remove and form a double bond there. So we need to take the functional to here, right? We need to take the functional to here. If you can come up with a double bond here, then that double bond can be converted to triple bond, right? That is how we are supposed to form the triple bond now. So triple bonds can be formed by first having the double bond there. So if you need a triple bond here, first you need to have the double bond here. Then adding two BRs and removing two HBr molecules will give you the 2 5 bonds. That is how we are supposed to, right, create the triple bond. First you need to come up with the double bond here. Then you can add two BRs by adding BR2. Then you can remove the 2 HBr molecules to come up with the 2 5 bonds here. That is how we are supposed to form the triple bond, right? So first of all, we should come up with the double bond here. So let's do the stuff, right? So we can add some H2O molecule here until you get the correct place for the functionality. Just repeat the same, right? So adding some H2O and remove some H2O there. That will give you the functionality to the correct place. Now we are happy. We are with a double bond at the between the two bonded carbons. So functional carbons are now achieved. So we are happy now. Now what we need to do is just change in the functional group. So double bond should be converted to triple bond. So that can be easily done by adding 2 BRs instead of the 5 bond. Then removing 2 of HBr molecules to give you the 2 5 bonds, right? So the reagents which are going to be added is actually to do this thing. You can add the consider H2SO4 to remove the H2 molecules, right? To add an H2 molecules, del H2SO4 to remove the H2, again consider H2SO4 with some heat. To add 2 BRs, so you need to add BR2. Basically, it comes up with CCl4 medium. So to remove the HBr molecules, 2 of those, you can add the alcoholic KOH. Right? That is how we are supposed to do this conversion. Right. Let's do the sixth one. 6th and 7th stuff are somewhat special, right? Let's see. 6th case. So you are starting with this one. CH3, CHBr, and another CH3. And you are supposed to produce this thing. Some NH2. This, see, you are starting with 3 carbon compound, and at the end as well you have 3 carbon compound. That is okay. That is okay. But in this case, you have the functionality here at the center carbon, but here the functionality at the corner carbon. So what we are supposed to do is just changing the functionality from center to corner, right? Such kind of thing. Functionality should be changed from center to corner. That is the thinking process, right? So you need to write this thing. මේ අරොස් දාන්න එපා මේ කන්වර්ෂන් එක කරද්දී වගේ. මම මේ හිතන හැටි මේ කියන්නවාට. මොනවද හිතන්නේ? කන්වර්ෂන් එක කරද්දී මේ කම්පවුන්ඩ්ස් දෙකයි රීජන්ස් එකයි ලියුවම ඇති හොඳේ මේ අරොස් දාන්න එපා. අරොස් දාන්න රවුන්ඩ් දාන්න එපා ඉතින්. හරි. අර ඕන මේ ලියා ගන්නකොට ලියා ගන්න එනවා කන්වර්ෂන් එක කරන්න එපා. හිතන හැටි තමයි මේවට උගන්න. හරි. එතකොට මොකද වෙන්නේ? ඔයාගේ ෆන්ක්ෂන් එක මේ කොනේ කාබන්ට ගෙනියන්න ඕන. To come up a corner carbon as the functional carbon. So we should do the opposite. The making වෙන්නේ මොකක්ද? Making වෙන්නේ functionality එක මැද carbon දෙන එක. Functionality coming to the center. නේ මෙහෙන් පටන් ගත්ත functionality එක මැදට එන එක තමයි මේක වෙන්නේ. සාමාන්‍ය අපේ normal technique එකකින් වෙන්නේ functionality coming to the center. The Markov flow and stuff will come up with functionality at the center ultimately. But if you need to do the opposite, so you need to come up with the anti-Markov. You need to come up with the anti-Markov. Anti-Markov කරන්න වෙනවා. නැත්තම් ඉතින් or opposite දෙක කරන්න බෑ. Functionally කොනට ගන්න ඕනේ anti-Markov යන්න වෙනවා. So anti-Markov can be done only with HBRs and only with the alkenes. Anti-Markov addition එකක් කරගන්න නම් අනිවාර්යෙන් alkenes වලට ගිහිල්ලා HBR දාන්න ඕනේ. R2O2 medium එකේ. හරි? Anti-Markov elimination කියලා ගන්න නැහැ හොඳේ. Anti-Markov elimination කියලා ගන්න නැහැ හොඳේ. Anti-Markov addition එකක් විතර තියෙන්නේ. So anti-Markov can be done only with the alkenes and with the HBr R2O2. මුලින්ම alkene එකට එන්න ඕන anti-Markov කරන්න. නැතුව anti-Markov එකක් කරන්න බෑ හරි. හරි එහෙනම් first come up with the alkene. So you can come up with the alkene by removing an HBr molecule here. So by removing an HBr, you will get the alkene. Br will be released with one of the hydrogens from these 2 carbons. So both are symmetric, so we can remove the H from here to come up with the Br here as required. So this is to do this just alcoholic KOH. Right. Now we can go for the anti-Markov to get the functional to the corner. See, with the anti-Markov addition of HBr, we get the functional to the corner. See, out of these 2 carbons, the hydrogen went to here, while the Br went to here. So H is added to carbon with low number of hydrogens, the anti-Markov. So now we are happy. We got the functional to the correct carbon, the carbon we need. Functional thing is done. Now just the converting the functional group, doing some makeups. That can be done with the use of note number 1 and 2. The makeups can be done with the use of note number 1 and 2. So that is just adding NH3 at this case, converting the Br to the NH2. right now. Some anti-magnetic thing was done to take the functionality to the corner carbon. I'll write it here. Anti-Markovnikov done to take the functionality to corner carbon. The opposite manner, opposite way, right? Okay, no? Right. So the thing is clear. Let's do the 7th one. So you are starting with this thing. Some NH2 is there. And you are supposed to convert that into a carboxylic acid. Right? Right? Okay. First, check for the carbon skeleton. Yeah, it is same. 3 carbon skeleton. Yeah, that is also same. Right? Then check for the functional carbon. Right? You have the functional carbon here, but in this case, it is here, the 3rd carbon. So function should be changed to a corner carbon. So the anti-Markovnikov thing should be done. Anti-Markovnikov thing should be done. So to do anti-Markovnikov, first you need to come up with a alkene. Only with the alkene you can do the anti-Markovnikov addition of a R2 to HBr. Right? So first let's try to come up with the alkene. To produce an alkene, first you need to come up with a Br or a OH. To produce an alkene, first you need to come up with a Br or a OH. Right? So let's do that. So we can convert this thing to OH, right, by adding Na into HCl. Then this OH can be removed to give you the alkene. So anti-Markovnikov can be done only with the use of alkenes. Right? So that we have to produce an alkene. This is the conc H2SO for what we need. So then we can go for anti-Markovnikov to add the Br to the corner carbon to come up with some functionality at the corner carbon. Always with the anti-Markovnikov, right, you can use the HBr R2O2, right? So only with the HBr we can go for the anti-Markovnikov, not with the H2Os. So only with the HBr we can go for the anti-Markovnikov, right? This is what we have done, is actually to come up with the corner carbon as a functional carbon. Right? We had done the anti-Markovnikov, right? To take the functionality to corner carbon. right now. Then now we are happy with the functional carbon. Now what we need to come up is with the carboxylic acid. So this is a carboxylic acid, right? The carboxylic acid. So how to produce the carboxylic acid? From here. So carboxylic acid is something containing oxygen. So to go towards the oxygen containing compounds, first you need to come up with the alcohol. Alcohols will be the bridge, provide the bridge to the oxygen containing compounds. So first come up with the alcohol. So you can convert this Br to the OH by just adding aqueous NaOH, and then you can do this thing by just adding H plus KMnO4. Alcohols can be converted to carboxylic acid with use of H plus KMnO4 or H plus dichromate. Right? That is what we have done. Right? This alcohol thing. This thing is converted to this. Right now? This thing is converted to this. Right. Is clear? That was a conversion, right? With H plus KMnO, this is converted to this. Right? With the same R root. That is not number 2, right? Okay, that is our final conversion. The last two is about taking the functional to the corner carbons, right? That can be done with use of anti-Markov rule. Remember, to do the anti-Markov, first you need to come up with the alkene. So that the thing should be converted to the alkene. Then the anti-Markov can be done with the use of only the HBr, HBrR2. Okay. Right now? Okay. That is your final question appearing at the page number 3. Right now. Okay. Let's move to the note number 4. Right. 3 things to check and pass. හරි. ඉතින් මේ තුන තමයි වෙන්න ඕනේ. කන්වර්ෂන් එක පිළිවෙලට වෙන්න ඕනේ. හරි. කන්වර්ෂන් පිළිවෙලට මේ තුන කරන්න ඕනේ. හරි. පළවෙනි එක correct carbon skeleton. අපි හැමතිස්සෙම චෙක් කරා හොඳේ. මේ දක්වපු පිළිවෙල අපිට ප්‍රශ්නයක් වුණේ නැහැ. එකම carbon skeleton එක තමයි තිබ්බේ. correct carbon skeleton. carbon skeleton හොඳේ. hydrogen ලා අර කෑලි කෑලි මුකුත් දාන්න නැහැ. carbon skeleton එක හරියට තියෙනවා. starting එකේ end එකේ carbon skeleton එක check කරන්න. අපි කරපු හැම එකෙම ඒක සමානයි. එතන වෙනසක් කරන්න නැහැ අපිට. හරිද? මෙන්න මේක ඊට පස්සේ. correct carbon as the functional carbon. Again, सरल कर लिया ना correct functional carbon. Correct functional carbon. तो अभी हम क्या ना functional to the correct carbon. දැන් ඕක තමයි ළමයි අපි ඉගෙන ගත්තේ note number 3 එකකින්. මේ වැඩේ කරන විදිහ තමයි ඉගෙන ගත්තේ note number 3 එකකින්. note number 3 එකකින් ඉගෙන ගත්තේ ඕක තමයි. කොහොම ෆන්ක්ෂන් ටික හරියට කාබන් ගේට ගන්න කියලා. මේ දෙක ඉවර වුණාට පස්සේ මේ වැඩේ ඉවර වුණාට පස්සේ තමයි වා කරන්නේ මොකද්ද? right correct functional group එක ගන්න එක. BR ලා NH2 කරන ඒවා NH2 ලා OH කරන ඒවා ඊට පස්සේ කාබොක්සිලික් කරන ඒවා ඒවා ටික කර අන්තිමට ෆන්ක්ෂනල් ගෲප් එක ගන්න එක හරියට. හරි. අන්න ඕක තමයි අපි අර නෝට් නම්බර් 1 and 2 වලින් ඉරගත්තේ. මේක තමයි අපි වගේ නෝට් 1 and 2 වලින් ඉරගත්තේ. හරි. ඉතින් ඔය ටික පිළිවෙලට කරා නම් ඔයාට කන්වර්ෂන් එක කරගන්න පුළුවන්. පිළිවෙලට කරන්න ඕනේ හැබැයි ඉතින්. හරිද? මුලින්ම මේ ෆන්ක්ෂනල් ගෲප් එක වෙනස් කරලා එහෙම හරියන්නේ නැහැ. මේ වැඩේ කරලා ඉවරන පස්සේ මේක කරන්න ඕන. පිළිවෙලට මේ තුන ෆලෝ කරන්න වැඩේ කරන්න පුළුවන්. හරිද? දැන් මම ළමයි මේ ඊළඟ ක්වෙස්චන් එක පොඩක් කරන්න. මොකද ඒකට ඔයාලට මේ මුළු ප්‍රොසෙස් එක ගැනම අවබෝධයක් එන නිසා නෝට් නම්බර් 4 එකත් මම කරන්න. ඒතර ඔයාලට තව සතියක් තියෙනවනේ මේ ප්‍රොසෙස් එක ගැන හොඳට හිතන්න. අපි දැන්ට මේ කල් ඉවර කරේ මේ දෙක. අපි මේ දෙක අපි ෆස්ට් ඩේ ඉගෙන ගත්තේ මේක. ෆස්ට් ඩේ ඩේ 1 වල ඉගෙන ගත්තේ මේක. දැන් අද දැන් කතා කරේ මේක. මේක කතා කරන්න නම් දැන්. අද ඉවර කරද්දි මේක කතා කරන්න. ඒතර ඔයාලට මේ හෝල් ප්‍රොසෙස් එක ගැන හොඳ අවබෝධයක් ගන්න පුළුවන්. ඒතර ඔයාලට ස්ටඩි කරන්න ලේසි. නැත්නම් අපි මෙතනින් නවත්තනට වඩා හරි මෙතනින් නම් ගත්තම හෝල් ප්‍රොසෙස් එක ඉවරයිනේ. ආයෙත් තව දෙයක් නැහැ නේ. ඒතර ඔයාලට මුල් ප්‍රොසෙස් එක ගැන අවබෝධයක් තියෙන ඊට පස්සේ ඔයාලට මේක ස්ටඩි කරගන්න ලේසි. හරි. අපි ඉගෙන ගත්තේ මෙහෙම පිටිපස්සේ ඉඳන්. හරි ලාස්ට් ඩේ අපි කරපු දේවල් වල හැමතිස්සෙම එකම ෆන්ක්ෂනල් කාබන් හිටියේ. එකම ෆන්ක්ෂනල් කාබන්ගේ ෆන්ක්ෂනල් ගෲප් වෙනස් වෙන එක විතරයි ලාස්ට් ඩේ අපි කතා කරේ. අපි කරපු ඔක්කොම එක්සැම්පල් ක්වෙස්චන්ස් තිබෙත් ඒක තමයි. හෝම්වර්ක් එක තිබෙත් මේක විතරයි. ෆන්ක්ෂනල් ගෲප් වෙනස් කරන්න හැටි. අද තමයි කතා කරන්න පටන් ගත්තේ අර වැඩි පටන් ගත්තේ මම කිව්වේ. අද කරන්න පටන් ගත්තේ මොකද්ද? ෆන්ක්ෂනල් කාබන් වෙනස් කරන එක. හරි. මේකත් අපි කරමු. දැන් මේ විභාගෙ ළමයි විභාගයේ මට්ටම මේක. විභාග මට්ටමේ විභාග ප්‍රශ්න මේ ඔක්කොම ටික කරන්න වෙනවා. විභාග මට්ටමේ කවදාවත් මේ එකක් දෙයක් කරන්න නෙමෙයි තුනම එක තමයි විභාග මට්ටමේ ප්‍රශ්නේ හැදෙන්නේ. හරි. එතකොට අපි බලමු මේ කඩේ. කොහොමද විභාග මට්ටමේ ප්‍රශ්නයක් කට යොමු වෙන්නේ කියලා. හරි මේ අතරම මේ කතා කරන්නේ ෆන්ඩමෙන්ටල්ස්. මේ තාම මේ කතා කරේ ෆන්ඩමෙන්ටල්ස්. මේ දෙකට වෙන ෆන්ඩමෙන්ටල්ස් කියලා. මේකත් එක තමයි වැඩි යන්නේ අතරම. හරි මේකත් එක තමයි කන්වර්ෂන් එකේ කතාව තියෙන්නේ. දැන් නෝට් නම්බර් 4 වල බැලුවොත් තියෙන්නේ ටියුට් එක ලොකු කතාවක්. මෙතන සුඟක් තියෙන කොස් වැඩ කරන් තියෙනවා. මේවට අපි කියන ෆන්ඩමෙන්ටල්ස් කියලා. කියන්නේ ඒවා නිකන් අර පොඩි වැඩ ටිකක් හරියට වැඩි කරගන්න හැටි කතාව. හරි. මේ අපි එක්සැම්පල් එකක් කරමු. මේකත් එක්කම පොඩි වැඩි කරමු. එතකොට ඔයාලට මේ තියරි කොහොමද කන්වර්ෂන් එකක් යන්නේ කියලා. හරි. එතකොට මේ අපිට ඊට පස්සේ එක්සර්සයිස් ටික කරන්න පුළුවන් වීඩියෝ එක තියෙන නිසා. වීඩියෝ එක බලලා. හරි. රයිට් අපි ක්ලාස් එකේ පොඩි එක්සර්සයිස් ටිකක් තව ඉවර කරන්න පුළුවන් ඒකට. හරි. සම්පූර්ණ අවබෝධය තියෙනවනේ වැඩේ ගැන. හරි. අපි එනකොට ඊළඟට යමු. ගිහිල්ලා මේ මම වැඩි දුර යන්නේ නැහැ. මම ඔයාලට මෙයාව ක්‍රෙඩිට් කවුන්සිලින් ලබා ගන්න ක්‍රම හුඟක් තියෙනවා. ඔය නෝට් එකේ වෙනවාදී. ඒකේ පළවෙනි විදිහට විතරක් කතා කරන්න. හරි. එතකොට ඔයාලට මේ idea එක ගන්න පුළුවන් වෙයි. right? So we'll first write the thing. මේක ලියා ගන්න ළමයි. අර page number 3 වල යට තියෙන ඊට ස්පේස් එකකට ඔන්න එක ලියා ගන්න. මේක තමයි අපි කරන්නේ. මුලින් මේ වැඩේ, ඒ වැඩේ ඉවරනට පස්සේ මේ වැඩේ, ඒ වැඩේ ඉවරනට පස්සේ මේ වැඩේ. ඉගෙනුවේ හැවතර උනාද දැන් කරන්නේ මුලින් මේ වැඩේ ඉවරයක් කළා තමයි මේ වැඩේට යන්නේ. මේ වැඩේ ඉවරයක් කළා තමයි මේ වැඩේට යන්නේ. වැඩේ හොඳට සෙට් කරගන්න මේ අපි තව ක්වෙස්චන් එක මේ තීර පැත්තක් කරලා දැන්ට යන්න. හරි. හරි ළමයි අපි වැඩේ බලමු. මේ මෙහෙම දෙයක් වනේ. හරි පොඩ්ඩක් සිම්පලි කියන්නකෝ එහෙම. හරි දැන් හිතන්න මේ දැන් අපි මේ දැන් මම ඔයාලට වුණ මුලින් කියලා දෙන්නම් මොකක්ද මේ කරන්න යන්නේ කියලා. හරි. දැන් මේ වෙලාව අපි මුලින් කරේ මෙහෙම දෙයක් නේ. හරි. what we have done so far is like this. පළවෙනි නැවත මම කියන අපි මොනවද කරේ කියලා හොඳට ඔයාලා ගන්නකෝ. first day අපි කරේ මෙන්න මේක. first day කරේ මෙන්න මෙහෙම දිනනවා. හරි. මෙන්න මෙතන ෆන්ක්ෂනල් ගෲප් වෙනස් කරනවා. මේක තමයි ෆස්ට් ඩේ වර්ක් එක. හොඳට බලන්න. හරි ෆස්ට් ඩේ කියන්නේ ගිය සතියේ. කියන්නේ මෙතන ෆන්ක්ෂනල් කාබන් එකම කාබන්. හරි කාබන් ස්කෙලටන් එකත් එක වගේමයි. 3 කාබන් ස්කෙලටන් ෆන්ක්ෂනල් කාබන් උත් එකමයි. ෆන්ක්ෂනල් ගෲප් වෙනස් කරපු තමයි මේ කරේ. මේ තමයි ඔය කරේ නෝට් නම්බර් 1 and 2 කියලා කරේ ඔක තමයි. හරි? නෝට් නම්බර් 1 and 2 කියලා කරේ ඕක තමයි. හරිද? ඊට පස්සේ දැන් අද දැන් මේ ටික වෙලා කරේ මෙන්න මෙහෙම දෙයක්. මම පටන් ගන්න ඉතින් කිව්වා ආයෙත් මේ කියන්නේ ඒකයි. දැන් කරේ මෙන්න මෙහෙම දෙයක්. දැන් කර හිටියේ නෝට් නම්බර් 3 කියන මෙන්න මේක. මේ වගේ ෆන්ක්ෂනල් කාබන් එකකින් ඉන්නලා නේ මෙතනට ගියා මේ. ෆන්ක්ෂනල් කාබන් වෙනස් කරන එක. අන්න ඕක තමයි අපි නෝට් නම්බර් 3 වලින් කරේ. හරි? මුලින් නෝට් නම්බර් 1 2 වලින් කරේ ෆන්ක්ෂනල් ගෲප් වෙනස් කරන නෙමෙයි. දැන් ඔය ලියාගත්ත එකත් බලන්න. ලාස්ට් ඩේ. කියන්නේ BR එක මෙහෙම කරන එක මේකනේ කරලා තියෙන්නේ. ෆන්ක්ෂනල් කාබන් වෙනස් කරන මේක තමයි කරලා දින්නවා. කරලා දින්නේ මේක. මේ කැල්ල මෙහෙම කරන එක කරලා දින්නේ. හරි එන්නේ CH2 නේ sorry. හරි. දැන් ඊට පස්සේ අද කරේ මේ වැඩේ. ෆන්ක්ෂනල් කාබන් වෙනස් කරන එක. දැන් කරන්න යන්නේ මෙන්න මේක. නේද දැන් කරන වැඩේ. දැන් කරන්න යන්නේ මේ බලන්න හොඳට. දැන් මං කරන්න යන්නේ ඔයත් එක්ක මෙන්න මේක. මොකද්ද? කාබන් ස්කෙලිටන් එක වෙනස් කරන එක. ඔන්න නෝට් නම්බර් 4. හරි? ඔහොම පුළුවන් නැත්නම් මෙහෙම පුළුවන් මේවා. මෙන්න මේක. Now this is note number 4. Right? We had completed these things. This is day 1, last day is today, the earlier section. Now we are leading up to here. වෙනස පේනව නේද? Carbon skeleton එක වෙනස් වෙලා. So here you have this kind of a carbon skeleton. Here it is like this. This thing is like this, the carbon skeleton. Here you are coming up with this. So here what we have done is we have added a new carbon to the carbon skeleton. අලුත් carbon add කරලා මේ new carbons to the carbon skeleton. That is what we are going to discuss with the note number 4. Adding one carbon to the existing carbon skeleton, that will be discussed today, now, and adding more than one carbons to the existing carbon skeleton, that will be done at the next class. යෝග තමයි දැන් කතා කරන්න යන්නේ. හරි? කොහොමද කාබන් ස්කෙලිටන් එක කාබන් එකකින් සෙට් කරගන්නේ? නැත්නම් කාබන්ස්ලා හුඟක් එකට වඩා වැඩියෙන් සෙට් කරගන්න කියන තමයි. Now we are going to discuss. Right? ඉතින් මේක හරි පිළිවෙලට යන වැඩක්. හරි? අපි බලමු. හරි එතකොට මේ so today I am going to discuss about this. This will be at the next class. Next class. Today. Then කරන්නේ ආයිත් යන්නේ. Now. බලමු එහෙනම් කොහොමද කාබන් ස්කෙලිටන් එක කාබන් එකකට සෙට් කරගන්න. හරි? ඒ කාබන් එකෙන් සෙට් කරගන්න. right? ඉතින් මේ වැඩේ ළමයි ස්කෙලිටන් එක හදාගත්තට පස්සේ මේ වැඩේ ටික තියෙන්නේ. හරි? ස්කෙලිටන් එක හදාගත්තට පස්සේ ඔයාලට කරන් තියෙන්නේ මේ ඉතුරු වැඩ ටික. මම අර ටොපික්ස් ටික දුන්නානේ මතකද? මුලින්ම කරනවා ස්කෙලිටන් එක හදාගන්න. ඊට පස්සේ ෆන්ක්ෂනල් කාබන් ගන්න එක. ඊට පස්සේ ෆන්ක්ෂන් ඩිෆරන්ස් කරන එක. ක්වෙස්චන් එක යන්නේ එහෙමයි. සෝල්ව් කරන්නේ එහෙමයි. ගෙන්නුවට එහා පැත්තට සෝල්ව් කරන්නේ අනිත් පැත්තට. මුලින්ම ස්කෙලිටන් එක හදාගන්නවා. ඊට පස්සේ ක්‍රෙඩිට් කාබන්ට ෆන්ක්ෂන් ටික ගන්නවා. ඊට පස්සේ ෆන්ක්ෂනල් ගෲප් වෙනස් කරනවා. right will do. වැඩක් කරමු. එතකොට මේ මොකද ඉරේ? හරි. right. Let's discuss about the techniques available. Let's discuss about the techniques available to do this change. To increase the carbon chain by 1 unit. Let's discuss the techniques available to increase the carbon chain by 1 carbon unit. Carbon chain එකකින් වැඩි කරන්න. So you are starting with 3 carbons, here the 4. Carbon chain is increased by 1 unit. So let's discuss the techniques available for that. Right? Okay, that is not number 4. Right. Let's come up with note number 4. Note number 4. Right? The topic says carbon count bond making or the elongating the carbon chain. Or elongating the carbon chain. Right? So here we discuss this topic with 2 parts. First we'll discuss how to elongate the carbon chain by just 1 unit of carbons. Then we'll discuss how to elongate the carbon chain with more than 1 unit. That is next day. Right? First thing is actually increasing the carbon number by 1 unit. Increase in the carbon number by 1 unit. Right? That is our first discussion today. That is our discussion today, right? This is all what we are going to discuss for today. Right. For this purpose, we have 2 techniques. The cyanide method and the formaldehyde method. We have 2 techniques for this purpose, to do this purpose, right? The cyanide method or the formaldehyde, HCHO method. Today we are going to discuss about the cyanide method, only the cyanide method. Right? Let's discuss about the cyanide method. 2 techniques available. The first thing is the cyanide. Right? Cyanide method. Right? Right. So with this technique, you are supposed to add the new carbon as a cyanide. Add the newcomer as a cyanide. That is what we are doing here. This cyanide contains some CNO. That will be your new carbon, which will be added to elongate the carbon chain by 1 unit. Let's see how to do this stuff. So cyanide method, right, can be done with the use of alkyl halides, aldehydes and ketones. Let's see how we are supposed to do this thing. Right? So you can start up with the alkyl halide. See, if you are with alkyl halide, right, if you can add some KCN, this alkyl halides, Kcn means K plus and the Cn minus, right? If you add some Kcn to the alkyl halide, what will happen? This Br will remove and the Cn will connect to that. The Br will remove and Cn will connect to that. Instead of the Br, some Cn will be connected. So you see, earlier you had came up with 2 carbons. Now you have 3 carbons. We are done. We have added 1 carbon to the carbon chain. Right? We have added some 1 carbon to the carbon chain. Right? See? So this can be done with the alkyl halides. What else? We can use aldehydes or ketones to do the same purpose as well. Let's see. You have started with an aldehyde or a ketone. Aldehyde or ketone. So if you are to add these aldehydes or ketones, so if you add this reagent HCA, if you add some HCA, not the KCN here, the HCN, what will happen? This 5 bond will break and oxygen gets the hydrogen and this carbon get the cyanide. This 5 bond will break and the oxygen get the hydrogen while the carbon get the cyanide. So it's like this. So this will be converted to CH3, C, oxygen get the hydrogen while the carbon get the cyanide. So you have started with 2 carbon compound. Now you are with a 3 carbon compound. So your carbon number increased by 1 unit. Increase in the carbon number of the carbon skeleton by just 1 unit. Here as well. See, oxygen gets the hydrogen of this thing and your carbon, instead of the 5 bond, the carbon gets the cyanide. So basically, out of these 2 guys, the oxygen is the negative pole. No? Negative pole gets the positive thing and the positive pole gets the negative one. Right? This is also polarized now. Plus delta and minus delta, H plus and the Cn minus. That is how the thing happens, right? So that is how you are supposed to add a carbon atom to your carbon skeleton. Just single carbon atom to your carbon skeleton. Right? This is the cyanide method. So after doing so, right? We can do this. So after doing this stuff, these cyanides can be converted to carboxylic acids or amines like this. If you add some water, this cyanide section will be converted to this. This is very familiar one for us. This cyanide section will be converted to this. Now you can handle this one with use of note number 2. So if you have to add some lithium aluminum hydride, in dry ether medium. So just the lithium hydride is also enough. If you add some lithium hydride to this one, this cyanide thing will be converted to CH2NH2. CH2NH2. Some amine. Now you clearly see, right? You have started with 2 carbon compound, and instead of this Br, you have added that third carbon. Now you are with 3 carbon compounds. See what has happened? See the change there? You had T2 carbon alkyl halide, so that Br can be converted to a new carbon. See, now you are with a 3 carbon skeleton, right? So these are familiar things, right? So this is some kind of NH2, NH2 at this carbon, right? So some familiar stuff appearing at the node number 2, right? That is how we are supposed to change your carbon skeleton by adding 1 carbon to it, right? Okay. So this is not a hard stuff, Lamai. This is not a hard thing to remember. The lithium and hydrogen stuff, right? So the cyanide means this, no, Lamai. Cyanide means you have a triple bond here between the carbon and nitrogen. That is the cyanide, no? So actually what is done here is these two polar 5 bonds was hydrogenated with the use of lithium aluminum hydride. So lithium aluminum hydride is the reagent which we use to hydrogenate the polar 5 bonds. We had done those things at the note number 2. Lithium aluminum hydride is used to hydrogenate the polar 5 bonds. So here as well the same thing is done. With the cyanide you have the triple bond, the 2 polar 5 bonds, those will be hydrogenated to give you the CH2NH2. Instead of these 2 bonds, you get the CH2NH2. Right now? So that is what we are supposed to do. The cyanide can be converted to those, right? Even with these ones, right? I'll come up with this one. Even with the aldehydes you can do, this cyanide can be converted to carboxylic acid or a amine, like that. So this is the carboxylic acid with plus 1 carbon. Right? Here, this is the amine with 1 carbon added. Amine with 1 carbon added. Right? See, with these things as well, you can do the same. With this one as well, right? So if you add some H plus H2O, this cyanide section will be converted to the carboxylic. Converted to the carboxylic. So this OH will appear like that. CH3 is there. But the CN will convert to COOH, the carboxylic, right? You can write like this, so the same thing, right? COH. If you add some lithium hydride, the CN section will be converted to CH2NH2. So you had produced some organic compound, some family organic compound with 1 carbon added to this carbon skeleton. See? So that can be easily done. So that is how we use the cyanide technique to come up with the carbon skeleton with 1 carbon is added. Right now? This is the use of cyanide technique. Right now? So you can perform the cyanide technique with the use of alkyl halides or aldehyde or ketones. If you are going with the alkyl halides, to the bromine connected carbon only, the CN will connect. To the bromine connected carbon only, the CN will connect, right? Keep that in mind. To the bromine connected carbon, the CN will connect. And new carbon will be added to that carbon. So Kc in this region, right? So if you are going with aldehydes and ketones to this oxygen containing carbon to the functional carbon actually, right? Always the new group is connected to the functional carbon. That's it. Simply as that. Always a new group, the cyanide group, connect to the functional carbon, right, of your compound. That is what is required, right? No? So to the functional carbon, the new cyanide group will connect. See the change, right? Okay. So this is the functional carbon. To that, the cyanide is connected. Now it is converted to COH, right? So the functionality also changes somewhat. Okay, that is how we are supposed to come up with a carbon skeleton with one more carbon added to it. Right. Let's use this thing. Let's use the knowledge we have gathered for a conversion. So with this one, you will get a complete idea how a conversion should be done. Right? Okay. So you can all these things are appearing. All these things are appearing with your note at the page number 4. Right? You can check those. Right? Okay. So I'll do a conversion. Right? So you have the page number 6, empty space there. So at that space, you can write the conversion I'm doing, right, for your references, right? So this is normal now. This is there in a note, right? Okay, I'll do a conversion with use of cyanide technique. See, so this is an example. Increasing carbon number by 1 unit, right? This is an example of cyanide technique. Right? At the page number 6, you can copy this one, right? The example, right? That space is given to copy this one, right? Okay, first of all, before copying, right, just discuss, right? Let's try to do this conversion, right? Let's do this one. So you have this one. This is what is required. No? Okay. So now you are supposed to do this conversion, right? You are supposed to do this conversion, right? Let's do it step by step. Do this one step by step, right? First thing to do, let's follow the rules. Let's follow the step by step, right? What I have written earlier in that box. First thing to do, what should be done first? Check for the carbon skeleton. Check for the correct carbon skeleton. That is the first thing. In a conversion, that is the first thing to do. Check for the correct carbon skeleton. Check for the correct carbon skeleton. Here you are with 3 carbons. Here you are with 3 carbons, right? But here you are with a 4 carbon skeleton. Just check for the carbon skeleton, right? Simply with this one you have this kind of a carbon skeleton. Here you have this kind of a carbon skeleton. That is all what you should look for. So you clearly see 1 carbon is added. 1 carbon is added. Actually, this carbon is added to this skeleton. This carbon is added, right? So that means this carbon section, this section is added. This carbon is added. That's it. Right? So here we use cyanide technique to introduce this carbon. We use cyanide technique to introduce this carbon. Right? Okay. So let's write it as from a cyanide. From a cyanide, right? This carbon is added as a cyanide. This is how we think, right? How we think. Because our first task is to coming up with the correct carbon skeleton, right? After that thing is done, we will think of the other steps. First thing is to come up with the correct carbon skeleton, right? Okay, so that is how we analyze this thing. You have started the 3 carbon skeleton, and you are supposed to come up with a 4 carbon skeleton, compound with 4 carbons, right? So you need to add 1 carbon to the skeleton. So that can be done with the use of a cyanide, right? So always the cyanides are added to carbons earlier with the halogens. Earlier with the halogen. So here that is the carbon with the alkyl halide. Right? To the carbon contained in the Br, the cyanide is added, no. Instead of the Br, the cyanide is added, no. Right? So to come up with this skeleton, first of all, you should have a Br at this carbon. You should have a Br at this carbon. Then only you can add the cyanide to come up with this skeleton. That is how we analyze. Our first task is to come up with the correct carbon skeleton. That is what we are doing. So we had 3 carbons, we have 4 carbons. So 1 carbon is added. That carbon is added to the center carbon. So that can be done by the cyanide group. So that first, before adding cyanide group, that center carbon should have a Br. That center carbon should have a Br. If you have to add some cyanide, when center carbon is with a Br, then only you get the correct carbon skeleton. Not from here. If you are adding cyanide here, මෙතනට cyanide කෙනෙක් add කරොත් මොකද වෙන්නේ? ඔයාට අලුත් CN set වෙන්නේ මෙතනට. ඔයාට මේ skeleton එක හැදෙන්නේ නැහැ. මොකද තේරුම් ගන්නවද? ඔයා නිකන් මේ ඔයාට 3 carbon හිටින්නේ 4 carbon කෙනෙක් ඕනේ. එහෙම කියලා කොහේ හරි තැනකට cyanide දැම්මම හරියන්නේ නැහැ. මොකද තේරුම් ගන්න. goal එක මොනවද ඔලුවේ තියන්නේ? goal එක. Goal is to achieve this carbon skeleton. Goal is to achieve this carbon skeleton. That is the first goal. After carbon skeleton is achieved, we can think of the second goal, to achieve the correct carbon as the functional carbon. After that goal is completed, we can think of the third goal to complete the process. ඔය steps තුන පිළිවෙලට යන්න. First goal එක මොකද්ද? To achieve the correct carbon skeleton. For that, the fourth carbon should be added. The fourth carbon should be added to the center carbon. To the center carbon, not to here. මෙතනට add කළා හරියන්නේ නැහැ cyanide. මුලින්ම cyanide මෙතනට add කරන්න. එතකොට තමයි මේ වගේ cylinder එක හැදෙන්නේ. So let's do the stuff. ඒ වැඩේ ඉවර කරලා පස්සේ දේවල් ගැන හිතමු. ඊට කලින් මෙන්න කිසිම දෙයක් හිතන්න එපා. හොඳද? මුලින්ම හිතන්න ඕනේ කොහොමද correct carbon skeleton එක හදාගන්නේ කියලා. ඒ process එක ඉවරුනට පස්සේ එන කිනි වැඩේ. අර තියෙන්නේ අර මේ සූරවප්පගේ තියෙන්නේ නේද? අර වැඩ 12ක් තියෙන්නේ. එක වැඩ පළවෙනි ඉවර කළා තමයි ඊළඟට යන්නේ. හරි. අයම හිතා ගන්න. හරි. මුලින්ම 12 වෙනි වැඩේ කරන්න යන්නේ නැහැ නේ. පිළිවෙලට යන්න ඕනේ. පළවෙනි දේ තමයි කොහොමද correct carbon skeleton එක හදාගන්න එක. Let's do that. හරි. දැන් අපි analyze කරා හරිනේ. දැන් වැඩේ කරමු. නම් මුලින්ම මොකද කරන්නේ මම කරන්නේ I am trying to come up with this carbon skeleton. I am doing all of this to come up with this carbon skeleton, that T-shaped carbon skeleton. Yes, let's do. So we need the Br here. Before adding the fourth carbon, we need the Br here. So for that, right? I need to take the functional to here. I need to take the functional to here. I need to take the functionality to here. The functionality is now here. I need to take that to here, right? To add the new carbon. My whole purpose is to copy the carbon skeleton yet, right? So CH2, removing HBr, then adding HBr. Br. Right. Now the functional carbon is there. To this, I am adding the KCN, the new carbon. Now I am happy. Right? You see? We got what we need, the carbon skeleton. Normally after this thing, let's come to the note number 3. Yes, we can come up with the note number 3. Right? Let's do that as well. Now anyway, we are happy. We have achieved the carbon skeleton. Right? By just adding lithium 100, we can do so. Right? Actually, the first step is done. We have achieved the carbon skeleton. See? Now this carbon skeleton is converted to this carbon skeleton. Now we are with this. See? We have achieved the carbon skeleton. Right? So the first step, first phase is done. In our conversion, the first phase is done. Achieving the correct carbon skeleton. First phase is done. Conversion එක කරලා තමයි phase 3ක් තියෙනවා මම ලිව්වේ. මුලින්ම වැඩේ හරියට carbon skeleton හදාගන්න එක. දැන් හරි. That is done. ඊට පස්සේ මොකද කරන්න ඕනේ? Functionality එක correct carbon ට ගන්න එක. Second thing is to bring the functionality to the correct carbon. But here you don't have such a functional carbon. Right? So no worries. A second step එක කරන් දෙයක් නැහැ. Functionality correct carbon ගන්න කියලා කතාවක් නැහැ. So finally, changing the functional group. So this is kind of an alkane thing. This is a amine, right? So you need to change this thing. To produce kind of alkane. කොහොමද alkane එක හදන්නේ? Alkane එක හදන්න පුළුවන් by alkene. If you had an alkene, you can come up with the alkane, right? So first come up with the alkene double bond. Double bond මුලින් හදමුනේ. You can come up with the double bond here by changing this into first OH. Double bonds can't be made by NH2s. Just changing that into OH, and then we can come up with a double bond by removing an H2O molecule. Right, H2 molecule. Right now, by adding conc nitric here in NO2HCl. This is a conc nitric, conc sulfuric. Now we are done. Just applying H2 nickel low H2PD. Right now, the conversion is තිබ්බේ ළමයි. අර මෙතෙන්ට එනකම් අපි කරේ මොකද්ද? This is the first phase. This is the first phase of the conversion. Achieving the correct carbon skeleton. Up to here, what we have done is actually achieving the correct carbon skeleton. Then हम करें correct carbon skeleton. Phase 1 එක. ඊට පස්සේ මේකේ අපිට phase 2 එකක් තිබ්බේ නෑ ළමයි. මොකද functional carbon කියලා එහෙම ප්‍රශ්නයක් තිබ්බේ නෑනේ අපිට. අර මෙතන ඉඳන් මෙතනට කරේ. මෙතනින් ඉස්සරහට අපි කරේ phase 3 එක. change in the functionality. Change in the functional group. Or the conversion can I? Alright, we can complete the stuff, right? I'll complete here. So to this thing, alcoholic QH is done. To change this one, just HBr. Rest are done. හරිනේ මේ ටික ඔක්කොම කරේ හරි කාබන් ස්කෙලිටන් හදාගන්න එක. හරියට කාබන් ස්කෙලිටන් හැදුණා ළමයි ඊට පස්සේ දේවල් හරි ලේසි. ඊට පස්සේ තියෙනවා වගේ note number 2 note number 3 change in the functional group කියලා කියන්නේ මේ වෙලේ මොකද්ද? note number 1 and 2 මේක note number 4 කාබන් ස්කෙලිටන් හදාගන්න note number 4 හරිනේ ටික උදා කතාව right ටක් ගාලා මේක ලියා ගන්නකො මම තව කන්වර්ෂන් එකක් කරලා වෙන්නම් ඊට පස්සේ වාට අර තින එක්සර්සයිස් ටික කරන්න පුළුවන් ඔය වගේ ටියුට් එකේ තියෙන දැන් මෙතනින් පස්සේ නම් ඔයාලට පුළුවන් කරන්න ටියුට් එකේ තියෙන page number 10 වල තියෙන ළමයි first 5 questions page number 10 වල තියෙන first 5 questions වලට කරන්න පුළුවන් හරි මම තව example එකක් කරන්න හරි මේක screen capture එකක් ගන්නකො හරි screen capture එකක් ගන්න ඔය ලියා ගන්න පුළුවන් මම තව වාට example එකක් කරන්න ඒකට වාට තව මේක හොඳට උඩට ගන්න හරි වැඩි යන හැටි right this is the last example so you can do the question numbers 1 to 5 at the page number 10 හරි page number 10 එකේ තියෙන question number 1 to 5 හදන්න ඔය පහ හදන්න පුළුවන් වුණා කියලා කියනවා ඉස්සර ඒව ගැන ඉස්සල්ලා ඒව ගැන worry වෙන්න එපා මේ 1 to 5 questions පහ හදාගන්න පුළුවන් වුණාට ඉස්සල්ලා ඒව ගැන worry වෙන්න එපා ඉස්සල්ලා බුරුවන් ඒ කියන්නේ පිටි වලට වැඩි යන්නේ හරි 1 to 5 ටික හදන්න පුළුවන් කියලා ඉස්සල්ලා බුරුවන් 1 to 5 හදන්න බැරි වුණොත් මොකද ඉස්සල්ලා බැරි නිසා තමයි මේ ප්‍රශ්නේ වෙන්න පුළුවන් හරි right හරි අය බලන්න මම තව එක්සැම්පල් එකක් කරගන්න මේ නෝවා වැඩි වට තීරම් ගන්න සයිනයිඩ් ටෙක්නික් එකට මම තීරම් ගන්න මම මේ ක්වෙස්චන් එක හිතන හැටි හිතන්න මීම දිනවා ඔහොම එකක් තිබිලා ඔයාලට හදන්න තියෙනවා මෙහෙම එකක් මෙහෙම දන්නකෝ වැඩක් කරන්න අපි වානක මේ වගේ කරමු හරි හොඳ කන්වර්ෂන් එකක් තියෙනවා අපිට කරන්න බලමු කොහොමද වැඩි කරන්න කියලා හරි right හොඳට ස්ටෙප්ස් ටික උඩට ගන්න ඕනේ මම කරන හැටි හොඳට උඩට ගන්න මම හිතන හැටි හොඳට ගන්න උඩට මෙහෙම හිතන්න ඕනේ හරි මුලින්ම කරන්න මොකද්ද මුලින්ම අපි කරන්න ඕනේ correct carbon skeleton එක හදාගන්න එක right ඒ කියන්නේ දැන් ඔයාලන් තියෙන්නේ මෙහෙම ගන්නේ ඔයාලන් තියෙන්නේ 3 carbon skeleton එක මෙතන තියෙන්නේ මොකද්ද 1 3 කොහොම හතරක් තියෙනවා මුලින්ම කරන්න ඕනේ මොකද්ද මෙයාව achieve කරගන්න එක හරි first task is to come up with the correct carbon skeleton හරි for that here we can use the cyanide technique මොකද we are starting with 3 carbons මේ 3 carbon skeleton එකක් තියෙන්නේ we are ultimately ending up with 4 carbons so just adding 1 carbon to the carbon skeleton so cyanide technique can be used හරි අපි මේලාර මේ alkyl halide එකකින් විතරක් වැඩේ කරමුකෝ. alkyl halide and cyanide කියන වැඩේට යන්කෝ. Cyanide technique can be used, right? So our task is to produce this one. Right? So you have 3 carbons. So one can say these 3 carbons are these, and this is the newcomer, and this is the newcomer. This is new carbon. පැහැදිලිද? දැන් අලුත් කාබන් තුන මෙහෙම නම් ඉන්නේ. මේ පරර කාබන් තුන නේ හිටපු තුන මේ තුනනේ. ඒ එහෙනම් අලුත් කාබන් ටික කනෙක්ට්ලා දෙන්නේ කොහොමද? කොනට. අලුත් කාබන් කනෙක්ට්ලා දෙන්නේ කොහෙටද? මෙන්න මෙතනට. අලුත් කාබන් කනෙක්ට්ලා දෙන්නේ මෙතනට. එතන ෆෝර්ත් කාබන් ඇවිල්ලා තියෙන්නේ. right? මෙන්න මෙතනට තමයි අලුත් කාබන් සෙට්ලා දෙන්නේ. මෙන්න මේ තුන තමයි මේ ඉන්නේ. මෙතන අලුත් කාබන්. This comes as a cyanide. This comes as a cyanide. This comes as a cyanide. ඒ කියන්නේ වාගේ මෙන්න මෙයා එන්නේ cyanide එකක් විදිහට. ප්‍රශ්න හිතන හැටි. මෙයා එන්නේ cyanide එකක් විදිහට. right? Introduce වෙන cyanide එකක් විදිහට. Introduce as a CN. හරි? introduce cyanide එකක් විදිහට. එහෙම වෙනකොට ඊට කලින් මෙන්න මෙතන cyanide set වෙන්නේ කාටද? මෙන්න මෙතන alkyl halide එකක් වෙන්න ඕනේ. මෙතන ඔයාලට තියෙන්නේ මොකද්ද? alkyl halide functional ටිකක්. හරි මෙතන Cl වගේ Br එහෙම දිනවනේ Br එක ගලවලා දාලා තමයි මේ cyanide එක set වෙන්නේ. මෙතන Br තිබුණා Br ගලවලා දාලා තමයි cyanide එක set වෙන්නේ. මෙතන කලින් Br තිබ්බ Br ඌව ගලවලා දාලා තමයි cyanide set වෙන්නේ. හරි? right. දැන් වැඩි හිටමු. හරි? එහෙනම් මගේ ටාස්ක් වෙන්න ඕන මොකද්ද? මේ ටාස්ක් වෙන්න ඕන මුලින්ම මෙතනට BR කෙනෙක් ගන්න එක. මෙතනට BR කෙනෙක් ගන්න තමයි මගේ මුලින්ම ටාස්ක් වෙන්න ඕන. එතන BR කෙනෙක් අරගෙන ඒකට cyanide කෙනෙක් දැම්මනම් ඔයාට මේ ස්කෙලිටන් එක එනවා. පළවෙනි වැඩේ ස්කෙලිටන් එක හදාගන්න එක. අපි හිතන්නේ කොහොමද මේ ඔක්සිජන් NH2 කරන්නේ? අදාළව නැහැ. හිතන්න එපා. ඔය මේකප් වලට රැවටෙන්නෙම එපා. මුලින්ම ස්කෙලිටන් එක හදාගන්න. ස්කෙලිටන් එක හැදුවට පස්සේ තමයි ෆන්ක්ෂනල් කාබන් එක සෙට් කරගන්න. ෆන්ක්ෂනල් කාබන් සෙට් කරලා පස්සේ මේකප් දාන්නේ. මේවා නිකන් these are just makeups, right? NH2 ද Br ද OH ද aldehyde ද ketone ද ඒවා මේකප්. ඔයාලා ස්කෙලිටන් එක හදාගන්න වැඩි තමයි අමාරුම. ඒක හදාගත්තා නම් මේකප් ඕන එකක් දාගන්න පුළුවන්. ඔය බය වෙන්න එපා. හිතන්න එපා මේ කොහොමද මේ ඩබල් බොන්ඩ් ඔක්සිජන් එක NH2 කරන අද අදාළම නෑ දැන්ට. මුලින්ම රන්නේ කාබන් ස්කෙලිටන් එක හදාගන්න එක. Introducing the fourth carbon here as a linear carbon skeleton. Right? Okay. එහෙනම් ඊට කලින් ඔයාලට fourth carbon introduce කරන්න මේ කොනේ carbon නිසා එයාට Br කෙනෙක් මුලින්ම අරන් ඉන්න ඕනේ. නැත්තම් ඔයාලට මේ skeleton එක හදාගන්න බෑ. Right. Let's do the stuff. හරි. ඔන්න වැඩේ කරන් යනවා. හරිද? එහෙනම් කොනේ carbon ෆන්ක්ෂනල් ටික ගන්න ඕනේ CN මුලින් set කරගන්න. හරි? හරි. එහෙනම් අපිට නම් බලමු කොහොමද? First of all, you have to go to anti-Markov to get the function to the corner. So that to come up with anti-Markov, first you should come up with the alkene. So this could be done with the lithium aluminum hydride, 2SH plus H2O. Then you can produce the alkene by getting rid of a H2O molecule. Now we can do the anti-Markov to come up to produce a Br. Now we are happy. Now I can add the CN to come up with the 4 straight carbon skeleton. Still we are producing the carbon skeleton, right? Still my main focus is to produce the carbon skeleton. Now the new CN is added. Now new CN is added. Right now? So this is just by adding KCN. So that can be converted to our known stuff. CH3, CH2, CH2. Cn can be converted to COOH as well. Or no stuff. It's now CH2 NH2 karat common. Both are same. Both will lead to the same product. No worries, right? Same kind of steps, right? So this can be done by H plus H2O. Now I am happy. Now my first phase is done. First phase is done. Now we have the carbon skeleton we need. 4 carbon skeleton. This is how we have first phase එක හරි carbon 3 තිබ්බ එක 4 කරගත්තා. First phase done. මෙතන නේද ඔයනේ first phase එක done. හරි. Up to here I have completed the first phase. First phase done. හරිද? පළවෙනි ඩේ හරි. එන්නේ coming up with the correct carbon skeleton. Achieving the correct carbon skeleton. That is done. ඒ වැඩේ හරි. හරි. ඒ වැඩේ ඉවර කරලා ඉතුරු දේවල් හිතන්න. දැන් මොකද කරන්න ඕනේ ඊළඟට? ඊළඟට කරන්න මොකද්ද? ඊළඟට කරන්න ඕනේ coming up with the correct carbon as a functional carbon. Correct functional carbon. Correct functional carbon. මේ why functional carbon ඉන්නේ මෙතන. මෙතන. why functional carbon ඉන්නේ මෙතන. functional carbon මෙතන ඉන්නේ. මේ correct carbon as a functional carbon. එහෙනම් ඔයාලට functionally මාරු කරන්න ඕනේ මෙතනට. Second thing. Right? Coming up with the correct carbon as a functional carbon. Functional carbon is මෙතන දෙවෙනි carbon ගේ. මෙතන තමයි functional carbon. එහෙනම් functionally මාරු කරන්න ඕනේ. functional carbon මාරු කර ගන්න ඕනේ. ඕකට තමයි අපි ඉගෙන ගත්තේ. What is that? That is note number 3. අද ඉගෙන ගත්තේ note number 3. මේ වැඩි කරන්නේ note number 3. හරි. බලමු කරන්න. මුලින් මේ නම් එයා මාරු කරන්න අර HBr H2 method එකට යන්න ඕනේ. ඊකට යන්න මුලින්ම OH එකක් තියෙන්න ඕනේ. તો OH එකෙන් තමයි Br එකක් ඉන්න ඕනේ. right? lithium aluminum hydride. හරි. දැන් මාරු කරන් දින්නේ යාළුවා. හරි. එහෙම කළා. coming up with the correct carbon as a functional carbon. Br දාගන්න පුළුවන්. හරි. දැන් මගේ second step එක දාන්න. මෙතනින් අපි first step එක දාන්න උනා. ඔන්න මගේ second phase එක දාන්න වෙනවා. මෙතනින්. ඉතින් මගේ second phase එක දාන්න වෙනවා. ඇයි? දැන් මම correct functional carbon achieve කරලා තියෙන්නේ. හරි. second phase done. What is that? That is achieving correct functional carbon. අන්න ඒක එතනින් ඉවර වෙනවා. regency දාගන්න. regency දාන්න පුළුවන්. conc H2SO4 and heating. This is just HBr. ඊළඟ මොකද කරන්නේ? ඊළඟට කරන් තියෙන්නේ එක ස්ටෙප් එක මොකද්ද මේ? Yes. Right. So I'll write it. Final step. What is that? Final step is just converting Br to NH2. For that, just adding NH3. So step එක කියන්නේ third phase එක. Achieving the correct functional group makeup දාන එක. අන්තිමට තමයි makeup දාන එක කරන්නේ. තේරුණාද? මුලින්ම හරි කාබන් ස්කේටින් හදාගත්තා. ඊට පස්සේ correct කාබන්ට ෆන්ක්ෂනල් ටික ගත්තා. note number 3 එක use කළා. right? මේ වෙලේ note number 4 use කරේ මේ වැඩේට. මේ වැඩේ කරන්න note use කරේ note number 3 එක. මේ වැඩේ කරන්න use කරන අපි note 1 2 දෙක. හරිනේ? තියෝම තමයි conversion එකක් කරන්නේ. අර පිළිවෙලට කරන් මුලින්ම correct carbon skeleton හදා ගන්නවා. ඊට පස්සේ නිවැරදි කාබන්ට ෆන්ක්ෂනල් ටික ගන්නවා. ඊට පස්සේ ෆන්ක්ෂනල් ගෲප් එක වෙනස් කරනවා. try එකක් දෙන්න ළමයි මේකත් උනා ලියා ගන්න. මේ ලොකුවට මේක පෙවුනට ලොකුයි දිගයි වගේ පෙවුනට මේක හිතන කතාවේ ලොකු දෙයක් නැහැ. මේක හිතන වැඩ ටිකේ ලොකු කතාවක් නැහැ. ওই කතා කාරණා තුන කරන් තියෙන්නේ. ස්ටෙප්ස් තුනක් හිතන්න තියෙන්නේ. මුලින්ම කොහොමද හදාගන්නේ? ඒ කියන්නේ මෙහෙම දකින්න ස්කෙලිටන් එක කොහොමද මෙහෙමයක් කරගන්න කියලා මුලින්ම හිතන්න ඕන. හතරක් කරගන්න. ඒ තමයි මේ ටික. ඊට පස්සේ කොහොමද ෆන්ක්ෂනල් හරි කාබන්ට ෆන්ක්ෂනල් ටික ගන්න. ඒ කොනේ ඉඳන් මේ අල්ලන් ආව මෙතනට. ඊට පස්සේ ෆන්ක්ෂනල් ගෲප් එක හරියට වෙනස් කරගන්න. හරි. ඉතින් ඔය ටික කරන්න මේක ලියා ගන්න right so you can take a screen capture as well right do this one so that is how we think of a conversion and do the 5 exercises appearing at the question page number 10 the first 5 questions with the question set 1 at the page number 10 do that theory කරන්න ළමයි ඒතර මේ ටික හරියයි අපි බලමු ක්ලාස් එකේ පොඩ්ඩක් කතා කරන්න මොන හරි අවුලක් තියෙනවා නම් ක්වෙස්චන් 3 කරලා අමාරු දෙයක් අහන්න වෙන්නේ. හරි right